In this section, we'll dive deeper into inherent controls. If you're a maintenance manager or engineer, this is your part to play in the hierarchy of risk controls. If your facility has engineering and maintenance, both parties should take this course and collaborate to determine how tasks will be executed. Neither party should assume the other party has taken care of it. Your workplace will be safer if engineering and the maintenance manager communicate and work together. If you're at a facility without internal engineering, these responsibilities all come down to the maintenance manager. You might need to bring in engineering contractors.
Remember, we outlined 6 primary areas of the hierarchy of risk controls, and they're divided into 2 sections, inherent controls and dependent controls. With inherent controls, safety is built into the equipment, and on the other hand, dependent controls require workers to carry them out. Inherent controls are much more reliable. The engineering or maintenance manager is in charge of developing and creating inherent methods. So, do you recall the 3 methods of inherent control? Don't forget that the sequence is based on their effectiveness: elimination, substitution, and engineering controls. Elimination is a complete removal of the hazard. An example of hazard elimination is stopping an unnecessary task that subjects a worker to a hazard. Substitution means replacing the hazard with a safer option. Substitution would include taking a voltage reading where there is a lower arc flash value. Engineering controls allow for the hazard, but isolate the worker from it. Engineering controls may include reducing the likelihood of an arc flash incident by installing barriers or finger-safe equipment.
What's our goal with inherent controls? We're trying to reduce the likelihood and severity in your facility to the greatest degree possible. Let's get to work, and we're going to do it hands-on by starting to identify the prime areas where inherent controls could make a difference in your facility. Go to this page in your manual, and before you start, make sure you have the common tasks form from the qualified workers in the previous section. You'll also need access to your facility. You can pause the video as you complete each section. If your facility is too large to complete this entire exercise, start by working on a manageable portion for now, and schedule time to advance this project when possible. And if you're not technically qualified to be performing this task, consider a qualified outside contractor for assistance. Now let's get started.
First, what are the risks of each common task being performed in your facility? Use the list of tasks from the qualified workers in a previous lesson as a starting point. Then, build out from there. List the tasks on the left-hand side of this table. In the next column, list the likelihood of an incident on a scale of 1 to 10, where 10 is definite and 1 is unlikely. This can seem somewhat arbitrary, so check out the graphic on this page to help you understand likelihood. Think about equipment age, equipment design, number of times an employee is exposed to the hazard, type of work being conducted on the equipment, skills/knowledge of the workers assessing the equipment, environment the equipment is located in, and other factors that can contribute to safety of the individual or team. Next, identify the incident energy level. This should be posted on the arc flash label. Use the graphic on this page to assign an A through E. Once you're done, organize your table in descending order so the highest values in letters are at the top. Looking at the table on this page, rank each of your hazards by assigning a level. You should immediately address anything that is a level A. notify management, and create a plan to address Level B. Level C should be addressed with management with additional controls applied. And Level D should be monitored and addressed using primary control methods 4, 5, and 6. Our goal here is to prioritize which equipment in your facility we should focus on first, and you might find other ways to determine this too.
Now that you've identified the equipment, use this page to identify any simple or low-cost opportunities to create an inherently safer environment. Breaker instantaneous levels are something that gets overlooked a lot. You might have found some arc flash levels higher than you originally expected during the arc flash study. If your system uses breakers with adjustable instantaneous levels and they're all turned to max, it's probably because maintenance staff adjusted the levels when troubleshooting a circuit with a tripped breaker. But this isn't the right way to troubleshoot. Most of the time, motor startup curves and circuit loading don't require the instantaneous setting on max. Before making changes to instantaneous levels, you should verify it won't cause nuisance tripping due to the loading on the circuit. You can figure it out through theoretical calculations or a load flow study. For more low-cost solutions, see this page of your handbook.
If you're upgrading electrical gear or installing a new line, this is the perfect time to introduce inherent control methods. Consider completing the arc flash study to help identify where current limiting fuses should be used prior to the equipment install. Your design might have excessively long cable runs or numerous step-down transformers that lead to a higher rating. You can address these issues prior to install. This page of your handbook has simple techniques that can help your team become safer with new equipment.
Beyond the low-cost efforts, the process can get more expensive and time-consuming. But you can stay on target by planning ahead. Focus on your highest priority area and create a budget and schedule to address equipment modifications and upgrades over the next few budget cycles. When you need upper management sign-off, make sure they understand the financial benefit new equipment can bring. Newer equipment helps increase runtime, reduce troubleshooting hours, and generally creates a much safer environment. Look on this page of your handbook for notes you can include in your bid specs to get engineering and contracting groups on board your safety efforts. It's common to request that all equipment be rated at 8 calories per centimeter squared or less, and that remote operation and maintenance switches should be part of a new equipment design.
The benefits of inherent safety controls will grow along with your facility. As the one in charge, this is your opportunity to help make sure your team is going home safe. A lot of times, no one knows your systems or processes better than you do. As you're implementing inherent controls in your facility, get creative and collaborate with the rest of your maintenance and safety team.
That's our section on inherent controls. Remember, electrical safety starts with the equipment, but creating inherent methods of safety doesn't happen overnight. It's an ongoing process that will probably span over multiple budget cycles and projects. Make the most life-saving tasks a priority. And don't forget, always try to create an electrically safe work condition and wear PPE.
The next steps will be meeting with your safety manager to review what you've learned in your sections. By combining inherent controls with what the safety manager is working on, you're both taking much more comprehensive approach to safety. You can expect the safety manager to reach out to you to schedule an hour to discuss your findings. Thanks, and be safe.